basketball. Hello. All right. This is the backside of chapter 4 review. We're going to test over this chapter tomorrow. We got through yesterday the first 6 problems. We are really laggy. Okay, we're really laggy, guys. Sorry. We got through the first 6 problems. I think we did number 6 together. So 4 and 5, you'll have to plug those guys in on your own. How many answers do you get for 4 and 5? And 6. 2 each, right? Because you have to plug in 2 and plug in -5, right? Okay. All right, 7, 8, and 9. Let's do one of those guys together. You can kind of maybe figure out the other 2. Which one do you want? 8? 7? 8?
Yeah, I do have one question. So is 8
We'll go through that. Should we ask number 8? Go through number 8? Okay. Number 8, describe the end behavior as part A. I'm going to write that over here. Let's see part A right here. So when you're writing the end behavior, we're really laggy. I'm so sorry. X goes toward infinity. Y goes toward blank. That's what you're filling out each time.
Why are you filling it out?
I don't know. If you want to put it after 8, you sure can. 8 goes here. I don't know. If you want to put it on the right-hand side, you sure can. I'm just doing it that way. I don't know why. Okay? So you're filling out each one of these. As X goes toward infinity, Y goes toward blank. As X goes toward negative infinity, Y goes toward blank. Okay? That's what you're filling out each time. Okay? And then we just have to fill in the blank according to that. Okay? It's kind of blurry and it's kind of laggy still. All right. X going toward infinity. When I say that, what direction are we talking about?
Yeah.
X goes toward infinity means we're going to the right, okay? And as this function is going to the right, it's going which way? No, we're looking at 8. Looking at 8, not 7. On the right side, he's going down. To the right side of the function, he's going down. So I'm going to put negative infinity here, okay? As X goes toward negative infinity, that's as he's going to the left. And as he's going to the left side of the function, he's going negative as well. So negative infinity there. Okay? And I'm really laggy again. I'm sorry. Okay? B is asking for whether it's an odd or an even function. So is this an odd function or an even function?
Odd.
Okay? All right. Odd functions? Yes. Odd functions go opposite directions. Okay? Take a look at this guy. He's going down and down. Odds go opposite directions. Evens go the same direction. So they can either both go up or both go down, but they're going the same direction. So is this odd or even? Even. This is an even function. Okay? Like he's x to the 2nd power, or x to the 4th power, or x to the 6th power, or any even exponent. Okay? What is this guy probably? He's probably a parabola, which is x to the 2nd power. He's x squared, right? Okay? And then part C says, how many zeros does he have? What is a zero? Where it crosses or touches. How many places does he touch or cross? I think it's only 1. Yeah, it does maybe kind of look like he goes up there and crosses twice, but I'm going to go ahead and say 1. I won't give you something that questionable on the test. Okay? We're just going to go ahead and say 1. And if I do, I'll accept probably 1 or 2 because I could justify and say that I'll take it if it's 2. I might give you one on the test that's 3. Like number 7, how many does he have? 6. 6 places he crosses, right? Yeah? So that's part C of number 7. Letter C of number 7 is 6. Okay? So those same steps, do that for 7, 8, and 9. We just did 8. Okay, there he is. All right, good? Okay, 10, 11, 12. These I don't really give you a whole lot of room here, but we'll make do. Which one do you want to do together? Or should we do all of them together? All of them together? Sure. Number 10. Let's start with number 10. What numbers do you want to plug in?
You should start with number 1.
During 5th period, we went -2 to 2 and we got the graph to look the way that it's supposed to. So let's just go ahead and do -2 to 2. So -2, -1, 0, 1, 2. And let's do that for all 3 of them. Okay? I'm going to make my graphs kind of tiny over here. -2, -1, 0, 1, 2. Okay? And then I'm going to do the same thing for 12. -2, -1, 0, 1, 2. Okay? We'll do all of them together if you want. I don't care. That's fine. just so we can plug stuff in. Okay. All right. First thing I'm going to do, we're going to do all three of these, the zeros to start with. If I plug 0 into number 10, 1. So this coordinate point right here is 1. Does that make sense? If you plug 0 in, it's like that last term. If you plug 0 into number 11, what do you get? -5. Okay. If I plug 0 into number 12, what do you get? -1. Do you see where those numbers are? Okay. All right. So we can go ahead and do those in our head, right? All right. Now we got to do the ugly stuff, and we got to actually plug stuff in. Okay. So we're gonna do that first. I don't know if I have room. Where do I have room? Let's go down over here. I'm gonna go down here in this corner. -2 to the third power. I'm gonna write kind of small. -2 times -2 to the second power plus 1. Okay. So Caden's got some of it. -2 to the third power, you said, was -8. Okay. Then what do you do? -2 to the second power is what you do first, which is 4 times the -2. 4 times -2 is another -8 plus 1. -15 to the third -2 times -1 squared plus 1. Okay, hold on. I gotta wait for it to catch up here. Okay, there we go. So what's -1 to the third power? Still -1, right? Okay. -1 to the second power, because you do the exponents first, right?
1.
Is 1 times -2. -2 plus 1. -2. Okay. So put -2 in that little box right there. Okay. Now we're going to do 1.
So it is 1.
So 1 to the third power -2 times 1 to the second power plus 1.
-2.
Okay. So 1.
-2 again.
This guy is 1. So -2 plus 1. That is
It's 1 minus 2.
1 minus 2 plus 1.
Yes.
0. So 1 is at 0. Okay. The last one that we have to plug in is
2.
2.
2 times 2.
2 to the third power -2 times 2 to the second power plus 1. Okay. 8 minus 8 plus 1.
Yes,
So
so 1.
1.
-15, -2, 0, 1.
Okay. So that guy's 1. All right.
So 1, 0,
Okay. So table. Looks like this. I'll wait for it to catch up. That's my table. -15, -2, 1, 0, 1. Okay, and we're going to plot those guys. Okay, -2 is at -15. He's way off the chart. I'm really glad that we started with -2 instead of -3, because -3 would have been really off the chart, right? Like really, really, really far off the chart. All right, so -2 is at -15. We're just going to put him a dot like all the way down here so we know where he's at. Okay, like all the way by the R on proving. Okay, -1 is at -2. Now we're on the chart. Okay, plotting the rest of them. 0 is at 1. 1 is at 0. 2 is at 1. Okay, now, before we connect the dots, this function is an x to the third power, right? What does an x to the third power look like? He's up and down, and he goes probably like that. Let's get it to quit lagging. Probably something like that. Can you see it doing that on the graph? He is doing something like this. Something like that. Okay? Now, some things that we have to label on here are the zeros, the maximums, and the minimums. Okay? So, how many places does he cross?
1, 2.
2 places. Okay? One of them is exactly at a good spot. So, he crosses at 1.
1, 0.
And we say between what 2 other places? He crosses at 1.
0 and -1.
And between 0 and -1. So he has a 0 at 1, and then the other one is between 0 and -1. Do you guys see that? Okay? The maximum. What's the high point? What's the coordinates of the high point?
0, 1.
0, 1. This guy right here. This is a max. 0, 1. Okay? The minimum? 1, 0. The reverse of that. Okay? That's all we have to label, and we're good. Okay, good.
Yeah.
Number 11. You ready for number 11?
Yep.
Okay, before we start number 11, what should number 11 look like? What should it look like?
Approximately up, down, up, down.
Okay, x to the 4th power is the parent function, or what he looks like, and Libby said a w, probably, something like that. He's positive x to the 4th power, so he should look something like a w. Let's see what he does. All right, -2 we're going to plug in first, okay? -2 to the 4th power plus 2 times -2 to the 3rd power minus 5. Bleh. All right, -2 times -2 times -2 times -2 4 times is like positive 16, I think. Okay? -2 to the 3rd power is -8, which gives me -16 minus 5. Okay, so that's at -5, all right? Okay, next one we're gonna plug in -1 to the 4th plus 2 times -1 to the 3rd minus 5. Okay, -1 to the 4th. What does that make?
It'd be a positive one.
Positive 1. -1 to the 3rd is a -1, which makes that 2 minus 2 minus 5. Okay, 1 minus 2 minus 5 is like -6, I think, approximately. Okay. All right, now we're going to plug in +1. So 1 to the 4th plus 2 times 1 to the 3rd minus 5. Okay, 1 to the 4th is 1. 1 to the 3rd is 1 times 2 minus 5. We'll let it quit lagging. I don't know. Right there. 1 plus 2 minus 5. Is that like at -2? -2? Okay, and then let's plug in a +2. So 2 to the 4th power plus 2 times 2 to the 3rd power minus 5. 2 to the 4th power is 16. Really? 2 times 2 to the 3rd power? That's really like 2 to the 4th power again. Isn't that 2 to the 4th power again? Because there's 4 2's, right? So that's another plus 16. Minus 5. 16 plus 16 is 32. Minus 5 is 27. Yikes. Okay. All right. So those are our things. Let's see if that gives me enough information. -2 is at -5. 2, 4, 5. Right there. Okay. -1 is at -6. 0 is at -5. 1 is at -2. 2 is at 27. Do we have enough? What? We need to do a -3. Okay, so let's go back through and do a -3. Yep. -3 to the 4th power plus 2 times -3 to the 3rd power minus 5. Oh boy. -3 to the 4th power is 81. Gross. -3 to the 3rd power is -27. 2 times -27 is -54 minus 5. 81 minus 59.
27.
No. 22. 22? Yeah, 22. -3 is at 22, all the way up here at the top. Blech. 22. Okay, so he's doing like something like this. It is a very dramatic W. The second little loopy thing doesn't actually come down. Does that make sense? Like there's supposed to be a hump right here where he comes back down, but he's not actually coming back down. So he's only doing like a very dramatic W thing. So that's what he was doing. Okay. All right. So let's figure out my zeros. Things that we need to label. We need to label the zeros. We need to label the maxes. and mins. Yeah, it's like a awkward parabola on the one side. Yep. How many zeros does he have?
2.
2, and they are between.
Negative.
It's
Negative 3 and
2
2.
and -3.
Between -2 and -3,
Yeah.
and between
1 and 2.
1 and 2. Between -2 and -3, and between 1 and 2. That'll work. Okay? Maxes? There are none. Okay, there's no really high hills in our thing. Do we have any mins, though?
No, -1, -6.
-1, -6. That's a minimum point.
So why does that one be a max?
So in order to be a maximum, it has to go up on the one side and down on the other side. So it has to be the highest place. But that one's going up on the right, on the left side, and then up again on the right side. So it's just kind of a point that's like living in between. Does that make sense? Yeah, that was a good question. Okay. All right, 12. Are we ready for 12? We have enough room? Oh boy. Okay, number 12. Plugging in -2. -2 to the 4th power plus 2 times -2 to the 2nd power minus 1. Okay. Because I have my old computer today, so I have to use this thing. I haven't done it. Well, kind of, yeah. I'm using it for something. All right, -2 to the 4th power. This guy right here, with the negative out in front of the whole thing, it kind of confuses things. We do the -2 to the 4th power first. -2 times -2 times -2 times -2 4 times is going to be a positive 16, I think. But now I have the negative out in front. So it is actually going to be -16. A lot of people think that that's going to be a positive 16, but the negative comes afterward. Okay? Then I do -2 to the -2 to the 2nd power, which is 4, so that becomes plus 8. And then minus 1. Okay? -16 plus 8 minus 1? -9. That goes in my chart there. Okay? -9. Now we're plugging in -1. So -1 to the 4th plus 2 times -1 squared minus 1. Okay? I do the -1 to the 4th power first. -1 to the 4th is a positive 1, but then the negative comes after that, right? So it is actually -1. -1 to the 2nd power is 1 times 2 is a positive 2, and then minus 1, so that is like a 0. Is that 0? Okay, now plugging in positive 1. -1 to the 4th power plus 2 times 1 to the 2nd power minus 1. 1 to the 4th power is what we do first,
1 would be 1
and then we apply the negative, so -1. Nope. What are you doing? Are you watching? I know, but what are you looking at? Okay. 1 to the 2nd power is 1 times 2 is positive 2 minus 1 is 0. Okay. Now, let me kind of show you some things about this function up here. We just got 0 again. Okay. So we have -9, 0, -1, 0, and then we haven't plugged 2 in. But take a look at the stuff that we're plugging in. We're plugging in x to the 4th power, and we're plugging in x to the 2nd power. So, because those are both even powers, every time we plug a -1 in, that's going to give us the same answer as what we get when we plug a positive 1 in, right? Because it's just going to change that and make it the exponent positive.
Yeah.
If I plug a -2 in, I got -9. Is that going to be the same as what I get when I plug a positive 2 in?
Yes.
Yes, because it's just going to make those exponents positive. Does that make sense? Okay. So this guy's going to be -9. So, yep, so everything's negative. That's why they give us mostly negative stuff on the graph. Okay. So -2 is at -9, 2, 4, 6, 8, 9. He's just ever so slightly off the chart right down there. -1 is at 0. 0 is at -1. Then we're back up here. Then we're down here at -9 again. Oh, wait. What is this guy supposed to look like? He's a -x to the 4th power. He looks like an upside down W or an N. So he'll look like this. Okay. Is that what he looks like?
Yes.
You betcha. That's what he does. Okay. All right, zeros. I'll put those over here. Zeros. What do we need? Maxes. Maxes and mins. Okay, so zeros. Do I have perfect zeros? You betcha. That's really nice. Where are my zeros located? Negative 1 and 1. Okay. Zeros are at negative 1 and 1. Okay, coordinates of maxes. My maximums are these guys.
Approximately.
Negative 1, 0, and positive 1, 0. And the minimum points? That guy right there? 0 and negative 1. There he is. Okay? Good? Those were all the graphing ones. You do have one like that on your test. It's not too bad to plug stuff into. That's not too bad. No. All right, so 13, 14, 15, the last thing is from section 4.7. They want us to figure out whether these are identities or not. What has to happen in order for it to be an identity?
Do the same on both sides.
Same on both sides. Okay, now, I'm going to do number 13 with you, and then I'll talk through number 14 and 15. But 13, let's take a look at the right-hand side first. We have two pieces on the right-hand side. You see that? The trinomial there, and then p minus 3. Okay? I don't want to multiply that together. What we can do is we can look at the left-hand side, and p minus 3 I see on the right, and I also see a p minus 3 on the left. Do you see that? There's a p minus 3 in both spots. So what I can do is to make life simpler, those p minus 3s are already the same as each other. What I need to do is these two pieces that are not the p minus 3 on the left side, I can multiply those together, and what do those have to be the same as?
P3 plus 3p.
This guy on the left side, or on the right side, right? The p3, yep. Okay, so do you see what we're doing there? We don't have to multiply everything by everything. If I just do those two pieces and see if it's that first piece, then I can kind of skip a couple steps, right? You do not have to multiply these in order. Like I wouldn't necessarily have to multiply these two pieces first. You can multiply the first one and the last one together. I'm really laggy, sorry. So let's start by taking, I'm going to go down over here. Let's start by taking p squared plus 5 times p plus 3. Okay, and we're going to multiply those two together first. Okay? All right, so FOIL, p squared times p to the third. Okay, then p squared times 3, 3p squared, 5 times p, plus 5p, 5 times 3 is 15. Anything I can put together for like terms?
Nope.
No. Okay, so I want to compare that guy to the stuff on the right-hand side in the parentheses. Is he the same?
Nope.
No. So either we did something wrong or he's not an identity. What do you think? He's not an identity because we didn't do anything wrong, right? We're too brilliant for that. Not an identity. Okay? All right, 14, 15. You guys can do this one. I'm going to talk you through it, though. The left side you can leave alone for both of those, but the right side, all you have to do is FOIL and see if he is the same. Okay? So FOIL those guys out on the right side, see if he becomes the left. If it does, you're good to go. If not, it's not an identity. Okay? Yes. Yes. Okay? Anything else you guys want to go through? All of them. Sure. We sure can. Okay. Libby wants to do number 5 on this page, so I'm gonna include it in the video. Sit. Come sit down. Number 5. We're gonna plug in 2 and negative 5. Let's plug in 2 first. I'm gonna do that over here. F of 2. 4 times 2 to the third is number 5. Minus 3 times 2 squared plus 2 times 2 minus 1. All that stuff. Okay, 2 to the third power is 8, and 8 times 4 is like 32. Okay, what do we do next for this part? We do the 2 squared first. A lot of people like to try to do the 3 times the 2, but you don't. You do 2 squared first. Then you take negative 3 times 4, so negative 12, and then plus 4 minus 1. Okay, 32 minus 12.
32 minus 12 is approximately
20 plus 4. 24 minus 1.
23.
23. There's my first answer. Okay. Then we do f of negative 5. Ooh, I'm running out of room. 4 times negative 5 to the third. This one's even worse.
4 times negative 5 to the third. Approximately 1, 2.
Yuck, yuck. Okay. Negative 5 to the third power. 5 times 5 times 5.
Negative 1.
Negative 125. And now we have to take that times 4. Negative
400. 500.
500 exactly. Negative 500 exactly. Okay. Negative 5 squared is 25 times negative 3. Like negative 75. Right? 2 times negative 5 is negative 10 minus 1. They're all negatives, so we just add them together, right? 50 plus 75 is 575. 575 plus 10 is 585. 585 minus 1 is 586 negative. Whoa, that's a big number.
When I first got that, I
Yep.
was like, oh, I totally did
That was
this
a
wrong.
lot. That was a lot of stuff. Yep. Number 4 is not so bad, but yeah, 5 and 6 are kind of gross. Okay. Anything else that you want to see on here? Study up on this review. If you can do all the stuff on this review, you'll be good to go. Okay. Long synthetic division. Make sure you know how to do that. Okay, that might be the stuff that you need to study on, maybe the most. Okay. The problem that I do on the homework assignment, or on the test, will be similar to 11, 12, 13, where I do. Once you do it long, once you do it in synthetic, then you plug it in and you find and you check your answer. Okay, so it will be kind of similar to that as well. Okay. All right. You people who are on the computer, do you have any questions?